Okay, so this is a circuit which can generate a square wave just from DC inputs. So let's see that generating it. As output sees, there is a square wave with output. Now, since this is in saturation mode, we need a positive feedback. Positive feedback means the output is going from pin number 6 to pin number 3, which is a non-inverting pin. In usual applications, that is, the output from pin number 6 is never fed to the non-inverting pin this way. So this means that the positive feedback means that the output is being fed to the non-inverting pin. Now, when there is no positive feedback, we make the assumption that there is a virtual short between pin number 3 and pin number 2. Virtual short means the voltage between these 2 points is very close to zero. But in this case, that won't be the case. In this circuit, that won't be the case. So let's see that. You can check the voltage difference between pin number 3 and pin number 2. You can see the peak to peak is 8.12, which is not close to zero. So we cannot make that assumption. Now, on the other hand, we can make the assumption that the current going into these pins is very small. Let's check that assumption. We can measure the current going in here, which is about 135 nanoamps, and let's measure the current going in here, which is 172 nanoamps. Since both these currents are very small, we can assume that the current going into these pins is zero. So now let's see how the circuit is actually working. Initially, if you assume that this capacitor is discharged, then the voltage over here is zero. And let's assume that the voltage over here is high. If the voltage over here is high, then half of that will show up over here because of this voltage divider. So that means the voltage over here will be higher than the voltage over here. And therefore, since the voltage at the non-inverting pin is greater than the voltage at the inverting pin, the assumption that the output is high is valid. Now, since this is high and this is zero, this capacitor will start charging through this RC circuit here. It will charge until the voltage of this capacitor goes slightly above the voltage at the non-inverting pin. When that happens, since the voltage of the inverting pin is greater than the voltage of the non-inverting pin, the output flips, going from positive to negative. Now, and then when this flips, the voltage here also goes negative. Now this here, before this was positive, right? So now since the voltage over here went negative, this capacitor starts discharging through this RC circuit until the voltage over here goes slightly below the voltage over there, in which case it flips again. So let's see that in this diagram. The blue one is the voltage of the capacitor, and the red one is the output voltage. You can see when the output voltage is high, the capacitor is charging, trying to reach that voltage. But as soon as it reaches a voltage which is slightly greater than this voltage here, the output will flip, and then the capacitor starts discharging. And as soon as it goes slightly below the voltage here, the output will flip and the capacitor will start charging. And this cycle repeats.